Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying the quadratic relations portion of the course. Since that portion of the course is divided into 2 units, we're going to call this quadratic relations part 1, and this is part of the review package as you prepare for the part 1 unit test. So, first of all, I have to apologize for my voice. I've been a little bit under the weather, but don't worry. Save your cards and letters and wishful thoughts. I'm feeling an awful lot better. It's just that my voice is still not quite back to normal. So maybe I'll try talking a little less than normal, although that's probably not very likely. I like to talk, don't I? Anyway, here are the 22 questions that I gave you as a review for this test. Each of these questions is worth doing. However, as always, you do the questions that you think are most important to you as you prepare for the test. What you shouldn't be doing is you shouldn't be staring at your video screen right now and trying to figure out what the questions are. You should already have a copy of this worksheet and you should have already tried all the questions. If you've lost the worksheet, please be sure to pick one up from me at school or by going to my Tumblr blog where you can download a copy. So let's go ahead and start question 1. Question 1 says expand and simplify. So here is where we're rehearsing how to work with binomials, because when you multiply 2 binomials together, the end result is often a quadratic expression. So how do we do this question? Well, one option you have is you could simply multiply -2 times this bracket, get a result, and then multiply by the third bracket. That's fine. There's nothing wrong with that. But as you should know, when you multiply and only multiply, it doesn't matter what order you multiply. It's something called commutative. So instead of multiplying by -2 first, what I'm going to do is I'm actually going to multiply the 2 binomials together, and then I'll worry about -2 at the very end. The reason why I'm doing this is because multiplying those binomials together involves a process called FOIL. And when I do FOIL, I'm doing it mentally. And the smaller the numbers are, the easier it is to do math mentally. So I'm going to leave -2 until the very end and do FOIL and everything else. So just a reminder about what FOIL is. FOIL reminds you that there are 4 steps to multiplying a binomial with another binomial. The steps are multiply the firsts together, then multiply the outsides together. Then multiply the insides together, and finally multiply the last pieces together. So it's just a little memory tool to remind you of the 4 steps. So firsts, outsides, insides, lasts. So let's go ahead and do that math and multiply using FOIL. So again, we're going to leave -2 to the very end, and we're going to do firsts, y times y, outsides, insides, and lasts. And now I notice that I have some simplification to do. I can collect like terms. So I'll do that next. I have -7y. And then my last step is I'm now going to distribute that -2 into the bracket. So, oops, almost forgot. So -2 times -7 is +14. Oops, I want my pen. So plus 14y. And then -2 times +12 is -24. I am having some issues with my pen, so you'll notice every so often dots showing up. That's me trying to calibrate my pen properly. So just ignore them. So that's what you should get in question 1E. You'll notice that expanding is the opposite of factoring. So let's look at another question. This is 1G. Again, it says expand and simplify. So now here, be very careful about what you do first. We have to always follow the rules of Bedmas. So the first thing you do is not, for sure, multiply by -4 into this bracket. Because if you do that, you're ignoring the exponent, which means you're violating Bedmas because you're doing multiply before you do exponent. So really, there's 2 ways to go about this question. One way is to do whatever exactly that squared sign says. So remember, if you square anything, it means multiply by the base twice. So you could start by writing this expression without the exponent sign. So in other words, take that exponent sign and write what it means. It means bracket twice. And then you could do it just like we did question 1e, where we multiplied these things together and then times -4. That's perfectly fine. But I'm going to show you, I'm going to do it by the method that I kind of prefer you do, which is that little mental shortcut. When you square a binomial, you should know that little mental shortcut: square the first, double the product, square the last. So again, I'm squaring the binomial, so I don't multiply first. So I'm going to square the first, 3x squared is 9x squared. I'm going to double the product. 3x times -5 would be -15x. Doubling that, I get -30x. And now I'm going to square the last. -5 squared is 25. So square the first, double the product, square the last. The reason why I'd like you to do that is because later on, if I ask you to factor this, the factoring of a perfect square trinomial makes more sense if you create a perfect square trinomial in that special way. So now that I've done squaring the binomial, no like terms can be collected. So I'm just going to multiply by -4. So 9 times -4, -30 times -4, and 25 times -4. And so there's my expanded and simplified expression. So the next one, 1J, says, again, expand and simplify. So here, when you look at this question, you should see that you have multiplication, subtraction, and multiplication. So obviously, I have to deal with both multiplication steps before I even think about doing that subtraction step. And one thing that I find very useful in a question like this is I'm going to actually put giant brackets. So I'm going to put one set of giant brackets here, and then a subtraction sign, and then another set of brackets here. And that will keep me focused on the fact that I'm multiplying, and finally subtracting. And it also makes sure that I give due consideration to this subtraction sign, because it'd be too easy to ignore the fact that that negative sign is really important for that second bracket. So let's go ahead and do this math. So the first binomials, again, I'm going to do FOIL mentally. So 2y squared, -3y plus 14y. So that would be plus 11y. Woo, good thing I'm doing it in my head. Minus 21. So here, that negative sign is here. So y times y and y times 3. So I did the first bracket. Now you'll notice I didn't show both of the separate middle terms. I just did it in my head a little slowly. -3 plus 14 is positive 11. Again, the more math you can do in your head, the better. Now I'm going to deal with this negative sign. So 2y squared, the first bracket is just exactly as it appears, and the second bracket is actually negative, so all the signs reverse. Now I'm going to collect like terms. 2y squared, take away y squared. So 2y squared, take away y squared is 1y squared. Then I have 11y minus 3y. So 11y minus 3y is, oh, positive 8y. My pen isn't working, so I'm not concentrating. Okay. And then finally, -21 is all alone. Okay, so again, make sure you remember bedness, bracket times bracket, and then worry about subtraction. 1m, again, similar idea, but even more expanded. So in this question, I have all of this multiplied together, then I have a plus sign and a minus sign, and then I have a multiply and a square. So according to the rules of bedness, the first thing I should do is that exponent. So I'm going to start there. Now, obviously, you can do a little more than I'm doing in each step as long as you remember the rules of bedness. But I'm going to completely do nothing other than square the binomial that has the exponent. Plus 9 minus 6. So again, when I square that binomial, I do it mentally. Square the first, double the product, so that would be -6, doubled is -12, and square the last is positive 4. So now, anywhere that I have multiply, I'm going to start to work on multiply. So again, I'm going to leave that negative 4, and I'm going to do these two brackets. So 4x squared, negative 10 plus 6 is negative 4x minus 15. And I'm going to multiply this bracket by negative 6. So that's one thing you can do. I did something different in a different question, but of course there's options. I'm going to treat this as negative 6 and multiply into the bracket. So what does that give me? Negative 54x squared, positive 72x, and negative 24. So again, negative 6 times 9, negative 6 times negative 12, negative 6 times 4. So I still have one more multiplication to do, and that's right here. I'm multiplying the first bracket times 4. So 16x squared minus 16x minus 60. Then I'm going to have a plus 9 and all this other stuff. So I've taken care of everything except for add and subtract. So my final step is just to collect like terms. So let's see what we have. 16x squared and negative 54x squared. So 16x squared minus 54x squared would be negative. I should have got a calculator. That's all right. I can do math in my head. 16 minus 56 would be negative 40. Nope, 38 x squared. Boy, I hope that's right. I'd hate to have to edit the video just because I can't do math. 16 minus 54 is 38x squared. And then I have, what's next? I have negative 16x plus 72x. Oh, math again. So what would that give me? That would give me 52. That would give me positive 56x. So plus 56x. And then what's left over is negative 60 plus 9 is negative 51 minus 24 is negative 75. So don't forget, again, bed myth. It's the little things that tend to mess us up. Not the big ideas, but the actual execution that you have to be as reasonably close to perfect as you can be. And then 1n. So again, I hope that you're used to squaring a binomial. So square the first, double the product, square the last. There's the big minus sign. Square the first, double the product, square the last. So now I just have to worry about subtraction. X squared, take away x squared, it's gone. 6x minus negative 6x. That's 6x plus 6x. And 9 minus 9 is gone. So the answer is just 12x. So now let's put some of the multiplying a binomial idea into some sort of application questions. So question 2 says to write an algebraic expression that represents the area of this figure. So the way that I like to think about the areas of figures is I like to say, okay, well, this is a composite figure. And what I see is I see a big rectangle like this with a piece cut out of it. So let's talk about how the size of the big rectangle. So we'll do area of the big rectangle. So area of a rectangle is length times width. So what do we know? Let's look at the length and the width of this rectangle. So the length right here is x plus 4. That's easy. Here's the width. So the width is made up of 3 plus x. So the area of that big shape would be, oops, x plus 4. And then we said 3 plus x or x plus 3. So we could say that the area of the big shape is x squared plus 7x plus 12 because I've multiplied them together. Now let's look at the area of the smaller rectangle, or the piece that's cut out. So the piece that's cut out looks like this. And again, it's a rectangle, so the area would be length times width, which are those numbers there. So the area of the small shape would be length times width. So that would be 5x. So take the big shape, subtract the small shape. So the area of the whole figure, or the figure that we're looking at, is x squared plus 7x plus 12, the big rectangle, minus the small rectangle, and that gives us x squared plus 2x plus 12. And similar idea in question 3. Now I want the area of just the shaded region. So again, I'm going to find the area of the whole shape, pretend that it's a whole shape. And then when I have that answer, I'm going to subtract the piece that's been cut out. So, oops, area of the whole shape, area of the big shape. So again, length times width. Well, if it's a square, then I can square it. So square the first, double the product, square the last. The area of the small shape, again, I'm told it's a square, so I can just take the side length and square it. So square the first, double the product, and square the last. So the area of the shaded region is subtract the two of them. So I'm actually just going to subtract them visually. So it's kind of neat because, for once in my life, I organized something. And you can see here that 9x squared, oh no, 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 yay for Control Z, that here I've lined it up so I can just visually do subtraction like this, the way that once upon a time you may have been taught to subtract binomials that way. So 9x squared minus x squared, 12x take away negative 24x, and 9 minus 144. It would be negative 135. So that's the area of the shaded region. Okay, so those questions reviewed binomials. Oh, one more. Okay, let's do this one. Now we have a rectangular prism. So that's a three-dimensional shape, often called a box. So there's my little sketch. It has a height of 3. It has a width of 2x plus 3. And it has a length of 3x. And it says write a simplified expression for the volume. So we know that volume is length times width times height. So again, it's just multiplying polynomials together. So I'm going to start with these two. So 3x times 2x, 3x times 3. And then I'm going to multiply it by 3. So I get 18x squared plus 27x. And that's the volume of the shape. And I think, yes, that's where this video ends. So make sure you're comfortable multiplying binomials times binomials. We often say make sure you can do FOIL. Make sure you understand how to quickly square a binomial. Make sure you understand bedmiss is always going to come into play and that you have to organize yourself so that you don't accidentally mess up bedmiss. Okay, so that's video number 1, and I apologize for my voice and for the pen messing up, but hopefully this helped you anyway. Okay, take care. See you at school.